Box plot from AI Engine and Python program, performance evaluations. Please subscribe to the channel and share it with your friends. Authors videos and white papers on AI engines. Pradeep K. Suri. Author, researcher, and AI-DNN architect. Book for your library. Scan QR code, bookstore in the cloud. Box plot. When looking at a box plot for employee performance evaluations in an organization, provides valuable insights into how performance is distributed across different categories, such as departments or genders. Here's a breakdown of a box plot in this context and how to interpret it. Components. Center line, median. This horizontal line in the middle of the box represents the median score for employee evaluations. Half the employees scored higher than the median and half scored lower on that particular evaluation metric, example self-evaluation, peer evaluation, manager evaluation. Box, the box represents the middle quartiles of the data. The upper half of the box shows the range from the 75th percentile, Q3, to the 100th percentile. The lower half of the box shows the range from the 25th percentile, Q1, to the 0th percentile. In employee evaluations, these percentiles represent performance scores. Whiskers, the lines extending from the top and bottom of the box represent the range of the data. Ideally, the whiskers extend to data points within 1.5 times the interquartile range, IQR. The IQR is the difference between the Q3 and Q1, IQR equals Q3, Q1. Data points that fall outside this range are considered outliers and are plotted as individual circles. Interpreting a box plot for employee evaluations. Distribution of performance. The size of the box indicates how spread out the performance scores are within the middle 50% of employees, between Q1 and Q3. A larger box suggests a greater range in scores for most employees. Performance differences. By comparing box plots for different groups, example departments, genders, you can see if there are any significant differences in performance distribution. O-center line comparison. If the median line, center, of one box plot is consistently higher than another, it suggests that one group tends to perform better overall on that metric. O-box size comparison. If the boxes for different groups are significantly different in size, it suggests that performance within that group is more or less varied. For example, a larger box for a department might indicate a wider range of performance scores within that department compared to another department with a smaller box. Outliers. Data points plotted as individual circles represent employees whose performance scores fall outside the expected range based on the IQR. These could be high performers, above the upper whisker, or low performers, below the lower whisker. Example. Imagine a box plot showing self-evaluation scores for two departments, sales and marketing. The median line for sales might be higher than marketing, indicating that sales employees tend to rate themselves higher overall. The box for marketing could be larger, suggesting a wider range of self-evaluation scores among marketing employees. There might also be a circle, outlier, above the upper whisker for a salesperson who rated themselves exceptionally high. Cautions and considerations. Sample size. The size of the group being compared can affect the box plot. With smaller groups, a single high or low score can significantly impact the median and quartile positions. Focus on improvement. While box plots can reveal performance gaps, it's important to use them alongside other data and feedback mechanisms to understand the reasons behind the differences. The goal is to identify areas for improvement and provide targeted support for employees. By understanding how to interpret box plots in the context of employee evaluations, you can gain valuable insights into your workforce performance and make data-driven decisions to improve overall performance and employee development. The equation IQR equals Q3, Q1 refers to the interquartile range, IQR, in statistics. It's a way to measure the spread or variability of the middle half of a data set. Here's a breakdown of the equation and its components. IQR, interquartile range. This represents the difference between the values that divide the data set into 4 equal parts. It focuses on the spread of the middle 50% of the data, excluding the most extreme values. Q3, third quartile. This is the value that separates the top 75% of the data from the bottom 25%. In other words, 75% of the data points fall below Q3. Q1, first quartile. This is the value that separates the bottom 25% of the data from the top 75%. In other words, 25% of the data points fall below Q1. How the equation works. The IQR is calculated by subtracting the value of the first quartile, Q1, from the value of the third quartile, Q3. This gives you the range of values that encompasses the middle half of the data set. For example, imagine a data set showing exam scores for 20 students. Scores: 50, 62, 71, 75, 78, 82, 85, 88, 90, 92, 95, 98, 100, 102, 105, 108, 110, 112, 115, 120. If you order the scores from least to greatest, the quartiles would be Q1, 25th percentile 78. Q3, 75th percentile 102. Calculating the IQR. IQR equals Q3, Q1 equals 102 to 78 equals 24. In this example, the IQR is 24. This means that the middle 50% of the exam scores, between Q1 and Q3, fall within a range of 24 points. Interpretation. The IQR provides a good idea of how spread out the data is in the middle portion. A larger IQR indicates a wider range of scores within the middle 50%, while a smaller IQR suggests the scores are more clustered together. Applications. The IQR is often used in conjunction with box plots to visually represent the distribution of data. It's a valuable tool for understanding how the data is centered and how much variability exists within a specific range, the middle 50%. Performance score compartment by department. Historical data 2021 to 2022 and 2024 is the prediction. The image is a box plot comparing average scores on performance evaluations, self-evaluation, peer evaluation, manager evaluation, broken down by gender, male, female. Here's a breakdown of the information in the box plot and how it can inform management decisions. Observations. Self-evaluation. Both genders tend to rate themselves highly, with females having a slightly higher average self-evaluation score than males. Peer evaluation. The peer evaluation scores are very similar for both genders. Manager evaluation. Managers tend to rate males slightly higher than females on average. Management decisions. Reduce self-evaluation bias. The gap between self-evaluation scores and manager evaluation scores, particularly for males, suggests a potential bias in self-evaluation. Here are some ideas to reduce bias. Training. Provide training on self-evaluation best practices, emphasizing the importance of objectivity and considering specific examples. Calibration sessions. Conduct calibration sessions where managers discuss how they evaluate performance and come to a shared understanding of rating scales. Investigate gender gap in manager evaluations. While the difference is slight, managers tend to rate males higher than females. Investigate the reasons behind this to identify and address any potential gender bias in performance evaluations. Here are some steps to take. Review process. Review the performance evaluation process to ensure it is fair and unbiased. Unconscious bias training. Provide training on unconscious bias to help managers recognize and mitigate its effects in performance evaluations. Multiple raters. Consider incorporating evaluations from multiple raters, including peers and subordinates, to get a more well-rounded perspective on employee performance. Important considerations. Sample size. It's important to consider the sample size for each group, especially when looking at small differences. A smaller sample size can make the average less reliable. Focus on development. Performance evaluations should be used for development, not just punishment. Provide clear performance expectations and tie evaluations to professional development goals. By considering these points, you can make informed decisions about how to improve the fairness and effectiveness of your performance evaluation process. Self-evaluation comparison across departments. For example, the plot might show that employees in the sales department tend to rate themselves higher on average compared to employees in the finance department. Observations from the box plot. Distribution: the boxes for all departments are fairly similar in size, which suggests that the distribution of self-evaluation scores is similar across departments. Median scores: the median self-evaluation score is highest for the sales department, 85, and lowest for the finance department, 77. Departmental comparisons. Sales: the sales department has the highest median score, and the upper whisker extends to 88, indicating that there might be a few salespeople who rated themselves very highly. Marketing: the marketing department's box mostly falls above the median line, and the whiskers extend fairly high, suggesting that marketing employees tend to rate themselves well, with a few outliers who rated themselves even higher. Finance: the finance department has the lowest median score and the upper whisker extends to only 82, which suggests that finance employees tend to rate themselves lower than employees in the other departments. There are also two outliers who rated themselves much lower than their colleagues in finance. Important considerations. Sample size: the box plot doesn't show the sample size for each department. A smaller sample size can make the median less reliable. Outliers: there are a few outliers in the data, especially for finance. It's important to investigate these outliers to understand why they differ from the rest of the data. Overall, the box plot provides a good overview of how self-evaluation scores are distributed across different departments. It can be a useful tool for identifying potential areas for further investigation or discussion. Thank you.